Okay, so today we're going to talk about friction. If I asked you what friction was, most of you would be able to give me an example. Probably the easiest example to think of is if you have your hands and you rub them together to create friction. The reason you want to do that is if you're cold and it creates warmth, right? So that's a good example, but we want to know in terms of forces what friction is. So for our example, we're going to talk about this definition. Friction is a force that opposes the sliding motion of two surfaces that are touching each other. Okay, so if two things or objects are touching one another, like let's say your hand, and this is the surface of your hand, this is your left, and this is your right hand, there's going to be some kind of force that opposes these hands from sliding together. That's why if you push them as hard as you can and try to do it versus if you gently move your hands past one another, it's easier. Okay, the closer you push your hands, the more friction or the more force that opposes that motion on two surfaces are going to occur. Now there's three different types of frictions that we're going to talk about, because even though we know that motion, the moving of hands, there's also a couple of different things we need to talk about. So the first one is a frictional force that prevents two surfaces from sliding past each other. So that motion, when you're trying to push something past, but it won't work, it won't push, so it prevents it, that's called static friction. It's making it stay. Okay, static means stay, so that's another way you can call it about stay friction or non-moving friction. Okay, the next type of friction is it opposes the sliding motion between two surfaces, so it must apply a force to continue sliding. So that would be if you were trying to move a box, say for example, and you were moving it across the room, and the reason why it doesn't just fly away whenever you're pushing it is because the surface of the box and the surface of the floor are coming in contact with one another, and there's a force that's trying to prevent that motion. Okay, it's coming up against the force of the floor and the force of the surface of the box. Another type of friction is friction between rolling objects. An example of that would be a train coming to a stop. It uses its brakes, and the combination of those wheels hitting a surface and a circular motion makes those wheels slow down, causing it to stop. Okay, so three basic different types of friction. Another type of friction that we don't often think about in terms of being friction is called air resistance. Okay, air resistance opposes the motion of objects that move through the air. So whereas the other three we're mostly talking about from one solid surface to the other, this talks about what happens when you move something through the air, say a person falling through the air. So it causes objects to fall at different accelerations and different speeds depending on the size, shape, and speed. Okay, and so since they depend on the size, shape, and speed, the air resistance will be different. So this is why a feather falls at a slower speed than a bowling ball, and these arrows are supposed to be right here. I'll just put them like that. So if you look at, for example, a feather, I'll quickly draw this. Okay, I'm just going to say this is a feather and here's a bowling ball. Okay, a couple things have to come into consideration. The surface area of this feather is a lot larger than the bowling ball. Okay, the air itself, little tiny molecules that we can't see in gas form are in the air. Okay, well, if you look here, all these gas particles have the chance to hit a surface area that's pretty big on the feather, versus here, not so much. So the air can't interact with the bowling ball the same way as it does with the feather. Also, there has something to do with the size of the bowling ball. Okay, it's going to create a greater force downward because of its mass than, say, the feather. Last thing we're going to talk about is what happens when you're falling and you reach a certain speed. Okay, the highest speed that you can reach while falling is called terminal velocity. It is a constant velocity, and so the net force is going to be zero, because the air resistance balances force of gravity and acceleration, so equals zero as well. So what I mean by that is there's a force that makes you fall, gravity. Okay, let's call that G. But also there's air resistance. There's molecules that are pushing up on you as you fall down. So they're going to create a force as well. So eventually, when you're falling, the force of air resistance and the force of gravity will equal out, and so you won't be changing your speed. You'll be falling at a constant speed. Once you've reached that constant speed, and again, this depends on the size, shape, and mass of what's falling, depending on if it's a person or a feather or a bowling ball or whatever it is. But if you yourself, for example, jumped out of an airplane, you know that if you would fail, you would be reaching a very high speed. Eventually, you would reach a speed of 53 meters per second. Okay. However, with an open parachute, your new terminal velocity is 5 to 10 meters per second. Okay, that's a lot slower. We can handle that. We can land and land safely if we have a speed of this. Okay, and the reason why this is the case is because if here's the parachute up here, you can see how there's more room for air to create a force on something, causing it to not go down as fast because of gravity. Okay, so these forces start interacting. It's almost like you can say that this force would be 10, this force would be 5, so this force is going to win. You're still going to fall, but not as far. You're not actually going to go up into the air, but you won't fall as fast. Okay, it does have some effect on it. Okay, so that's all for now. Make sure you've got all the words highlighted in red, the numbers in red, and the arrows, and that'll be all. Thank you.